having some issues with the mic. Good morning. Thank you for joining us today in this panel. We will be talking with Beto about the Bt technology in soybean. So I'm Franco Bardeja, technical advisor for the regional office Los Urgentes. I will make a brief introduction based on data from the REM of Aapresid that is organizing this talk to give you some context about the topic of this meeting. For those of you that are not aware of the work that the network, the REM of Aapresid, has been doing with the companies and farmers from the different regional offices of Aapresid, this is a survey that is conducted every year. It started in the season 2019-2020, and there we collect data on diseases, pests, and weeds in almost all the region where the Aapresid regional offices are located, as you can see them in the map. To give some context to this talk, here we have some data about the Bt technology adoption in the past few years in the different regional offices of Aapresid. As you can see, in 2022, or until 2022, it was widely used technology in the north of the country, where the Lepidopterus pressure is an issue for farmers. That's why it was rapidly adopted there. Then, as from 2022, we have two situations. On the one hand, the introduction of varieties with Bt technology with a high potential. They introduced them in the core region. And on the other hand, as you know, the release of the royalties for the technology that also had a huge impact on the acreage used. It reached 40% of the soybean acreage among the respondents with Intacta technology mainly, and some Conquesta technology. And this increase in the acreage of soybean with Bt technology also brings about the lack of adoption of shelter in the area. As you know, the main objective of the shelter is to maintain the technology. It was not accompanied with this increase in the acreage, so we have this issue here. They started noticing the presence of Lepidopterus and damages in the crop. As you can see, in 2024, almost 70% of the farmers that adopted this technology observed direct damage on the crop. Mainly the Rachiplusia worm that was quite stable in 2022 in terms of species of these worms. In 2023, 2024, when we started seeing more damage, we saw that Rachiplusia was the main caterpillar that was affecting Bt soybean, followed by sometime Poligera. Based on the damage observed, these are maps from 2019-2020 and 2021-2022. Very soon we're going to have the maps from the latest season. And what we are starting to see is that from the north of the country, that's where they started to see the first damages in this Bt soybean. They started to control the caterpillars to reduce the population pressure. And during the subsequent seasons, those pressures to control the caterpillars came closer to the core region. So this is a good point to pass the floor to Beto to see what he can share. about this advancement in the acreage, these damages in the Bt soybean, and this technology that we don't see it's working as in previous years. Perhaps should we keep using it, or perhaps we've lost a great technology? So I pass the floor to Beto for him to tell us something about this. Good morning. I'd like to thank Aapresid for the invitation and thank you for the opportunity of hearing about and talking about different topics, not only the leaf hopper. And the idea of this conversation, they always ask me what do I do for a living. I'm a monitor. I'm a crop monitor. That's what I do. So I monitor the management in the field. I'm going to show here, an attorney shared this with me somehow. The fact is before the right. These are not the exact words by Rudolf von Hering. He was an attorney from Germany. But what did he mean by this? That the fact is before the right. I mean, because you legislate what exists already. This happens to us with the resistance and with the intact soybean, the intacta soybean. If we see the official records, SIDA and VIMO, that's where resistance and monitor and management is registered. We see that for the Atrea saccharalis and for Spodoptera frugiperda, it is registered. But so far, there's nothing officially published about the behavior in soybean. I mean, for the world, Argentina has no resistance of the Medidora caterpillar in soybean. But we know these are control failures. That's why this idea about monitoring, that when you start observing things about the monitoring, sometimes the information is not yet developed. So you have to be careful in your suspicions. So under that idea, I start thinking, what happened? What have we seen in the evolution? And when you start observing the region and you start studying and seeing what happens in the region, to see what happens then in our own region, in our fields, Brazil issued their first release in 2021 of the first failures in soybean with the CRY1AC protein. The thing about Brazil when this happened was that the main lepidopter is Chrysodexis in Brazil and not Rechiplutia. And the first failure they have is in Rechiplutia. There were also people working on research from Obispo Colombres in Tucumán, speaking about unexpected damages in the 2020-2021 season. We believe, well, in the north of Córdoba and also in the south of Argentina, perhaps it was not observed because of the low pressure of Medidora. So the cases, it started in the north and then moved down to the south. It was difficult to say that because of the lack of monitoring in some regions. Some other regions monitor more, but that was not observed. But throughout the region, this is from Uruguay, they work online. And this is a publication from 2023, but they had been seeing failures from 2022. So that is, the whole region, they were using a single technology, and there was a lack of management of that technology throughout the region. So that started calling our attention. In Córdoba, we organized a meeting that is a monitoring meeting, and we invited Brazilians to talk about this and Geves to tell us their opinion. The question was, is there Medidora resistant in Argentina? That was 2022-23. And he said, of course there is, even if it's not officially reported. And there's a very interesting paper presented some time ago of a PhD student, an entomologist from Brazil, that speaks about the genetic variability of the lepidopters in the southern cone. And they found that in the south, that is the center of Argentina, the humid pampas, they found the highest genetic variability of Rachyplusia, more than in Brazil. So they said that if it became resistant in Brazil, genetically, our Rachyplusia had more probabilities of becoming resistant because it has more genetic variability. It was obvious that Rachyplusia was coming to Argentina. So I'd like to clarify some concepts. Perhaps sometimes we don't think about these concepts. Resistance, understanding that it's a process that some authors describe as a microevolution. It happens a long time and through the different generations. The evolution can be fast or slow, and that's the most difficult thing to measure with the models. But we should know it's something that is an evolution that is in the genetics mainly. So there are many definitions. They are not all complete because many definitions of resistance are not for transgenic. For instance, this definition of McGray. Then you have another definition, for instance, of the WHO. He describes it mainly for insecticides, but not for transgenics. Others are more pragmatic. Other definitions that we have found, for instance, this one by Crow. He says resistance marks a genetic change as a response to the selection. That is, all the things you did made this variety become resistant. But this has to do with the management. Everything has to do with the management. So today, the Bt technology in soybean was presented for this issue. And what the REM showed is that, if we can say what favored us in Argentina, was the increase of the corn acreage compared to soybean. The growth in the soybean acreage in the year 2000 and 2010 was exponential. It grew a lot. I don't want to mention the governments that were there at the time, but that is because of policies that favored a crop to another. When corn started to grow, well, the sea of soybean disappeared and started becoming islands. So that management perhaps has delayed the appearance, but it was obvious that our management was going to bring it. So these definitions, beyond which one is better or not, has to do with how we were managing. We know it's that resistance marks a genetic change. And the other definitions that are for insecticides, when they speak about population in the GMOs, they speak of individuals, not population, because they try to find the resistance gene of the individual and see if there's a probability for that gene to be expressed in the population. That is the big concern. And there are definitions that describe this very strongly. For instance, the definition, this one, it's a phenomenon by which an arthropod population develops resistance to a compound or a selection agent, whereas at the same time it becomes resistant to a second agent. That's why it's cross-resistance, because sometimes you use a technology and you don't think of the other technology that can also generate resistance, even if it has never been used. We've experienced this with corn, and we forgot about it with soybean. It's amazing how we experienced it with corn, and then we forgot we experienced it with corn. 10 years later, 40% of the monitors were renewed. I mean, 40% of those that diagnosed plant health did not see what happened 10 years ago. So that mass will observe the fact before observing the right. And this is what happened in the fields. Today we are here. We have two technologies. There's a third technology for control of lepidopters in soybean, and that is Intacta. We know that is absolutely released, and the one that is approved, that is the Conquesta technology. It's Intacta plus the protein of our old HX corn, the Hercules, 1F. Why do we mention this, and why do I mention the doubt whether it's crossed or not? Because this work by Colombres for 2022 for Conquesta showed that it worked very well, but the next season already finds that Conquesta does not have the same response for R no. So we have to know that all the technology for control of for Rachyplusia no is not working. So we should know that the management today of the defoliating Rachyplusia no is not going to be done with the Bt technology. It has to be done with another management, knowing that soybean has many other lepidopters. So this is related to the question, what should we do about the future? Should we keep using this technology? Only one species is now well evaluated and has advanced in its tolerance, resistance to that technology. The other species have not done so yet. We have Anticarsia. These are some that are not in soybean. Eliotis virescens, but these are works that show the activity of the protein on the different species in comparison, and you see the difference of susceptibility in the species. Eliotis has a very high sensitivity to the protein, CRY1C. So we extrapolate for our, where there are not many works about this, for Geotopodeum, but there's a high sensitivity. Anticarsia, still very sensitive. Spodopteras were never very highly sensitive. That's why we have the Conquesta technology for them. And these works, these are lab works, help see the evolution. It doesn't say whether, this data is for a true monitoring of the resistance, see the evolution of the problem. This should be done every season. If you ask me personally, Argentina doesn't do much about this in pests. When I see who works in resistance in pests in Argentina, there are very little local information to see what management to set for the future, not only for the Bt technology, but also for insecticides. This is also I included this because it says Lecover Pasea versus Eliotis virescens is 100-fold difference in resistance. So the main thing about monitoring is to be pragmatic, to have information, to then decide what to do. It's the other way around, not say what to do and then what I have. In general, plant health is managed like that. And based on our management, the technology sometimes, because of the biology, has different timelines. And these are the different timelines. You see Spodoptera for corn, 3 years was the time to resistance. Others were longer. It has to do with the frequency of the resistance gene in the population, and it has to do with our management, how we do the selection, and also because of the characteristics of the pest. Remember, it's an evolutionary process, and it happens through the different generations, the descendants. So we have to start thinking about the old species that I'm leaving behind. I'm turning them into something resistant. So everybody asks, how do I avoid resistance? This is a very complicated thing, because avoiding resistance is talking to us. And sometimes we don't agree in a group. Imagine agreeing all farmers, all advisors on a same management for resistance. So how to avoid resistance? Well, the main limitation is us, not the biology. So we always say it's much easier to avoid it, to avoid resistance, than to revert it. Always. It's much easier to avoid it, prevent it, than reverse it. But anyway, when the problem happens, everybody says, what do I do now? Well, you run into the worst problem, that is how to revert it. You should have avoided it. So the second is reduce the selection pressure. And that's the other question. How do we do it? How do we reduce it? This requires a global management. And when you speak of global management, that's the issue, because it's not just inside each field, but at a regional level. And you have to start regionalizing this. This is just the historical perspective. This is for insecticides, but it's the same evolution. you see how you select, you increase this process that has to do with the number of descendants and how many times you do selection pressure and how many generations I have a long time. It's very important to understand this, why there can be different speeds. So when the levels of resistance evolve a long time, you have to do your work there. And now Argentina, I think, has never done it, because if I see how we've managed the corn refuge, when we started having the corn issue, we started speaking of refuge. Speaking of soybean, it's very difficult for me to find refuge in soybean. I don't. So we're moving upwards. Sometimes the biology forgives us, and it doesn't build it so fast. It's a big problem if the evolution is very fast. And there are lots of papers about how to do this refuge, beyond the fact whether the resistance is recessive or dominant. It can be faster or slower, but if everything is recessive, even if it's recessive, you have a homogeneous population. This is what I show in most of the Bt technology. And this, I don't have official data from Argentina. This was published in Brazil, and it shows the percentage of refuge as the technology was adopted, as more Bt soybean technology was used. You see the difference in the refuge. It's almost none.
Based on the proportion of seeding moist soy. This is an idea of area, and over time, from 2015 to 2020, how the proportion came down in Brazil. It's a mirror of what is happening here. The more Bt technology was seeded, the less proportion. And when it got released, it was amazing. When the technology was released, it was even worse. Everybody seeded this technology without asking whether there was any refuge. In corn, there is no seeds of their own. In corn, the thing is that lot 10, well, has refuge. I have this under monitoring. And I say, this is not a refuge lot. It is not any such thing. In soy, that doesn't even exist. So selection pressure is even greater, and they've been quite forgiving. So in genes, we enumerate the genes. It depends on their domination, on the dominance, and we have to look for information. We cannot manage genetic directly once we find it, but we can manage selection. Genetics. In biotics, the number of generations per year, the greater the number of generations per year that I may have based on the same technology, the better the chances to choose. If a pest has one annual generation, of course, the selection pressure is far less if I use technology for a pest that is in 15 generations. So if I think about the worst pests in generating resistance is Tripsia granuella. The cycle goes 15-20 days. If I see bed bugs, they go from egg to adult 35 to 42 days. So it's 3-4 generations. So that also shows the difference, the number of offspring they may have. This is why there are pests that are more reactive to resistance. Migration may play a role as well. It is not well studied. We do suspect it. There's papers that show that Pedoptera can travel from Miami to Canada. There are very interesting genetic papers that show it. In South America, we don't see how much it moves. But there's lots of these concepts that we need to see how we manage them. So Bt technology does offer a big advantage. So far, there is one single one that has escaped, but there is another one that is quite interesting, and we see full protection. And this is the caterpillar, Helicoptera gletopoeon. The management possibility, it is easier to manage this caterpillar than others. So the message is do take care of technology. It started faulting, but it gives us a chance. Understanding the generations is interesting, not just for Bt, but for pesticides. In the north of Córdoba, we have measured that we have between 3 and 4 generations of Helicoverpa helotopoeon in summer. This is on the winter legumes. In spring, this is the first generation. And in the north of Córdoba, we have beans, or peas actually. And then we have a third generation, the one that eats other things other than grains. In soybeans, it faces 2 generations. The policy to avoid resistance is to alternate the mechanism of action between generations rather than between applications. This is why in Bt technology you cannot rotate the mode of action, and refuge is important because you are applying it every second. Here the thing is that you may find this, and it's the same insecticide that will be used in the third generation. And you may say, I rotated. I did apply on the first generation for Gelotopoeon. I now go back with diamide there. But that doesn't mean to have rotated, because I am doing the same thing to the 2 successive generations. So when it is to manage resistance, we have to assess several guidelines. How do I have to alternate technology and how to protect? This is something that we may not be seeing in the field, and we are generating a lot of confusion in the window of application of insecticide, how to protect Bt technology and what product to use. I feel sorry for the sector. When you see for a number of pests, they don't have that many APIs, but for Lepidopteros, it is the pest that has more different mechanisms of actions. So if we do not rotate, it is for a productive decision. It is not an ideology or a market issue. We are not doing it. So what happened with this? And it keeps happening. This is just to see some myths. When I travel, I go to the gas stations and I see these bags. This goes back to 2007. This is in Jesus Maria. I was really surprised by the number of the moths that I would see there. This appeared in January, and it started appearing late. That's Rachyplusa. And everybody said, what is the mechanism in generations? I took this photo on April 2023, in April 15th, and this was the big peak. This campaign where Medidora appeared, they said, well, what happened that Medidora appeared in January? It got kind of late, and then, well, it became normalized. We are adjusting the date to seed, and it was normal. So we don't communicate what happened before to the millennials. And one of the problems here in taking a look at the fact is that metabolism depends on temperatures. This is an example where we have a clear understanding. When there is a low thermal amplitude, we find these dark green and light green. The greater the temperature, and there is an ideal temperature, the pest can have greater toxification mechanism. The metabolism is accelerated. We see this thesis by Adriana Saluso. I found it fascinating. She showed me several parts of her research. What is the behavior of Rachyplusia in soybean and in sunflower? Well, you see far bigger in sunflower than in soy, non-Bt soy. And what this chart shows is the rate of growth that is measured here based on the temperature, and there is an optimal one. So it's happened to us that they considered that with Bt technology, the caterpillar would go slower because it had to detoxify. In just one season, they said, no, it is quite quick. This is quite strange when you compare temperatures. The year it went slow with Bt technology was because nights were quite fresh. But then when nights were warmer, it got accelerated. It was a temperature thing. And this happened the season before the last one, that is in 22-23, where there were very high temperatures and these attacks were faced. And this is why when it attacked, I started seeing these charts per day to see what the problems were. Lots of meats were generated in connection to resistance. The data is true. And they found that there was resistance in all insecticides. It was an application problem. Conditions were really nasty when this got applied. Why? Because early in the morning, humidity dropped suddenly with very high temperatures. It was really difficult to come to this. And the complex thing of chemical control is it was in the middle of the leaf, where it was really difficult to reach. So setting this with millennials is defoliation. We are used to seeing it spotless, but now you see it a little eaten up, and the sector gets despaired, and in such a way that I'm kind of seeing how we are not explaining things well. This is defoliation. It doesn't even reach 3%. This was extremely harmful, and we have to remember, or actually remember, what is the goal here? The goal is to protect something. It is to protect the active foliar area for the campaign. And this is what the management basis is considering. How many green areas do you need? And it's not just the amount, but the function. And this is what is complicated. We are not paying attention to biologic control. Last campaign, it was wonderful in soybean in all the country. I monitored in different places, and I found it everywhere. There was this peak in January, and I said, well, Rachyplusia will be terrible in February, but it didn't develop. Copidosoma, and there were many more around that were quite good. But this is not just what you see in soy, the defoliation affecting the leaves, but it has to do with function. And how do we have to see it in the system? This is an old photo. This is the spot or rust. It is contradictory environmentally speaking, because one is the result of droughts, the other is the result of humidity. This was by Rossi, Labaque, and Guerra. It's good to also include Peralta, but I actually did not participate much. They did this interaction. It is fabulous, and they are doing this. It's to see Aranuela and trips and see the interaction with the use of pesticides. So this is the control, fungicide or pesticide, and the application of them in combination depend on the timely moment for pest or disease. And the campaign that was a terribly dry season, the difference can be seen in connection to the pests with trips and others. But there was synergism with the pesticide or the fungicide, even though the season was dry. When the time came to apply this for the main diseases in Córdoba, we see a very big difference in the number of leaves and in the function of them. And well, these are the leaves, and this got extrapolated to yield. What could be seen was amazing, and even though the differences were not statistically significant with the double application of insecticide, when one or another was applied individually, we did see differences. We protect the number of leaves because of defoliation, but we forget about the functionality, and integral functionality, because they reduce foliar area and functionality. This campaign, when rainfall was better, once again This is an example, fungicide, insecticide, and the interaction of the two of them with a very similar result. But since it rained more and since there was less pressure because of hydric stress and because of less pressure of Aramella, then fungicide was better, but protection of both gave a better response and a better yield for Bt technology. And the future of Bt technology, if we keep seeing it as something isolated where the problem is today, this is what they considered, that the big biopter in the north got massified and that was it. But if we don't integrate it, then days will be counted for them. Last year, I had to go to present in Tandil. They would talk about soy being without a refuge in the south of Buenos Aires, Córdoba, and Santa Fe. Rocky Prussia is the source of keep doing the same because there is no management policy. If we do not integrate all this, then this will happen. As Mark Twain said, it is based on knowledge we do a terrible thing. It is not what you know what gets you into trouble, but that which you know with certainty, and it turns out not to be that much so. So sometimes I believe things are in a way, but then they are not that way. And this happens with technology. I am managing it in this way. I don't see the problem, and I am certain that it is not like that it works okay. But all of a sudden, your certainty was wrong. So knowledge, you always have to assess it. You always have to assess and ponder it and see how we progress it season after season. Thank you so much.
Beto, muchísimas gracias.
Thank you so very much. We are kind of running short on time, but if you do want to ask any questions on the very clear and informative presentation by our colleague here, you can scan the QR code that is shown on the screen. And in the meantime, I will take advantage to ask a question. Maybe we won't be taking back home a recipe, but we can start thinking about the following situation in the future, irrespective of Brachyplusia, considering the other caterpillars that are controlled by Bt technology. What would you prioritize in this comprehensive management to stop them from generating any further resistance? You can enumerate factors, whether they favor or they don't. And that's quite an interesting mess. Among the factors that would favor, then we know the refuge problem, the high dose relation for it to work. We say we are not doing refuge, something in favor of the technology so that there is no resistance generated. We are adding another mechanism of action. So those that are escaping intacta has to be defended from insecticide. So we would be protecting against polychaeta, but we have to be careful. There are papers where we need to be careful with persistency. Sometimes we cannot rotate. So having products with high persistence is equivalent to not rotating. And there is a wonderful paper that shows that how using IGR in refuge had a less larvae, and it was similar to soy Bt. So you have to give an opportunity to the susceptible offspring. What I see today is it may take a while, but if it becomes massive, it will be a problem. If it comes behind and the seed companies issue very few seeds that are intact, they will help maintain it, but that is complex.
Acá, bueno, llegan preguntas frente a un posible...
In front of a possible scenario of full soy in the north, how would lepidopters behave and pests in general? Because of chicharita and there is increased soybean surface, what would be the case with this increase as compared to lepidopters and pests in general? I am in contact with people from the Northwest when they say corn is not any feasible. Well, we know that soybean single crop is difficult for picudo. With lepidopters, what we do, it is not that there will be any more lepidopters. That's too long ahead. But since they have more food, they have higher populations. In the latest populations, in the last seasons, in the north of Cordoba, 10, 15, some cases with 20. Sporadically, they might be 30, but in 2005, 2004, it was, finding 40 or 50 of them in every lot. Pigs were 100 in some cases. So if we go to an ocean of soy, that will be the scenario. And you have to be highly proactive. This is what you have to think about. In closing, two more questions that are quite interesting for us to start working in the subject matter. First, is there any technology that will come along in the future that will exceed Intacta or Conquesta? Have you ever heard anything in connection to this? And the second question, even though you showed something in connection to the environmental conditions, why you applied this in this season for lepidopters, do you have any comment as connection to whether there is any sort of chemical resistance generated by this? The information I manage, my source of information is Fernando Flores from Marcos Juarez. He's been working with this, with diamines and Brachyplusia. And so far, no change has been seen in the tolerance of the populations that he assesses. The defect of that information or the flaws is that it's just local for that region. Is the same happening in Charata, Chaco? I don't know. He's not assessing further away. So there's more efforts needed. But theoretically, it's not moving for Brachyplusia in connection to chemical products, to the well-known, because pyrethroids, the oldest ones, in the 1990s, with half a dose, we would control them, okay, but not today. But we don't have the baseline to compare against. So it's difficult to compare. If you ask me where I do see the control failure of Brachyplusia in soy, it's in application technology. It's not only the dose, but the moment when it is applied. I always like to draw a parallelism with the minimum nutritional law, and sometimes they discuss the product and the dose, and they discuss as to whether they have to add any nitrogen. Well, nitrogen is fundamental, but in the application and in the control system, application is nitrogen. If that is not okay, then the other thing doesn't even count. And I saw this in this season where there were doubts about the product, and Brachyplusia attacked us in Bt and B4 with soy, and all applications worked fine, but they did fail when we are at R2 and R3 blindfoldedly. So when you see the same sector, the same farmers in the same season, the same thing happens, it's not a problem of the product and the pest, but the application technology. I focus a lot on this.
No tengo ni idea.
If anyone does know, please raise your hand. I don't really know whether there is any new technology for soy. They are working on corn, but we'll have to wait for a long time. But not that I know in soy. So thank you so much. Thank you for your presentation, and I'd like to thank participants for their questions. Thank you. Keep enjoying the Congress.